Hi children, so in this video we are going to discuss that how to find that square roots. What we discussed in the previous video, that is properties of square roots. Okay, so here finding square roots, by prime factorization method. So this is that first method. We are having some methods, okay, division method. Next one, that is, so finding square roots by prime factorization method. So by using that prime factorization method, how to find that square root? Okay, so my question is here 225. Find the square root of 225. Find the square root of 225. So here first we need to write that prime factorization of 225. Okay, so this number multiple with 5, no? So 5 4s 20, and here that is 5 45s. 5 4s 20, 5 5s 25. Okay, so next this is multiples with divides with 5. So 5 9s 45. Next 3 into 3. Next 3 into 1. Clear? So what is the prime factorization for that 225? That is 5 into 5 into 3 into 3. 3 into 3. So now we need to find that square root of 225. So we need to find that square root. So how we can write this one? This is square root of 225 is equals to square root of 5 into 5. We can write this one as a 5 square into 3 is equals to 3 square. Okay, already we discussed in that properties. What is that? If that square root is in the form of square root of AB, we can write it as square root of A into square root of B. So apply that property here. This is in the form of square root of A into B. We can write this one as square root of A into square root of B. Here A is equals to 5 square, B is equals to 3 square. So square and root gets cancelled. Here also square and root gets cancelled. So which is equals to 5 into 3. So 5 3 is 15. 5 3 is 15. Is it clear? So 15 is the square root of 225. If you have doubt, then check it. 15 15s. Already I told you that you have to learn the square roots up to 25. 20 I told you, right? So 25 better to learn. So 15 15s 225. Okay, so what is the square root of 225? That is 15. By using which method we did here? By using that prime factorization method. Okay, I'll give you one more example. 65. Square root of 65 I want to find out. Square root of 65 by using prime factorization method. So 65 prime factorization is 5 into how much is equals to 65? 5 13s. 13 5 is 65, no? So here prime factorization is 5 into 13 only. Why? Because 13 is a prime number, we know that. Okay, so here prime factorization is 5 into 13. Okay, so here is it a square root? 5 into 13 is the square root of that root 65? No. How we can say that? Square root means that must be consisting here which numbers, which prime numbers we are getting, that numbers should be in the form, its powers should be having that even powers. Powers should be even. For example, here 5 square into 13 square is there. So we can write this one as a 5 into 5. This is 13 into 13. Why we need to take this one as even numbers? Means here square and root gets cancelled. Then we will get that 5 as the square root of that one of the number. One of the number I am saying. Okay, here 13 square and root gets cancelled. So 13 may be the square root of that some number. Okay, but here, for example, 5 power 4 into 13 power 4 is there. So we can form here ordered pairs 5 into 5 into 5 into 5. So we can write this one as a 5 into 5, 5 into 5, and here 13 into 13, and here again 13 into 13. Like this we can write, no? Okay, why? Because here this is square, cancel, square we can cancel, here square we can cancel, here also square we can cancel. That's why here powers should be even. Powers should be even. For example, like this there, ma'am, 5 square into 3 power 5 is there. Is it a perfect square or not? How we can check that? Yes, 5 square is there, so we can say that 5 square. What about that 3 power 5? 3 power 5 we can write it as 3 square into 3 square into 3 only, no? 3 square cancel, 3 square gets cancelled, here square gets cancelled. What about this 3 here? That is not possible, no? So that's why this is not a perfect square. This is not a perfect square, and in the same way this is also not a perfect square. Okay, that is also not a perfect square. Okay, that should be in that prime factorization, that numbers should be formed as ordered pairs. Then only that one possible, then only we can say that that is a perfect square. Okay, I'll tell you one more example here. 4 power 5, 5 power 4, okay, 2. Is it a perfect square or not? Is it a perfect square or not? My doubt here. So it is a perfect square. How we can say that? Here 2 power 5 is there. 2 power 5 is there means, okay, here square is there. Is it a perfect square or not? How we can check? Yes, 4 power 5 we can write it as 2 square, no? Why? Because we need to write that one as a prime factorization. So this one we can write it as 2 square power 5, and this is a 5 power 4, and this is 2 square. Okay, so that's why here 2 power 2 into 5 is equals to 10, and this is a 5 power 4, this is 2 square. So we can form this one as a 2 into 2, one ordered pair, and here 2 into 2, next 2 into 2, next 2 into 2, next 2 into 2. So 2 square, 2 square, 2 square, 2 square, 2 square. Okay, square and roots gets cancelled. So in this all cases we can take that here 2, 2, 2, 2, 2. Like that only we will get. Why? Because square root of 2 square. This one also square root of 2 square, square root of 2 square, square root of 2 square. Square root and gets cancelled, no, here. So that's why we will get in all cases as 2 only, no, again. Okay, that's why here this is a perfect square, we can check that. Okay, here 5 power 4, 5 into 5, 5 square, again 5 into 5, 5 square, square roots gets cancelled. Next 2 square, square and roots gets cancelled. So we can find here. So that's why this is a perfect square. In this method we can check that given number is a perfect square or not. If that is a given number or that number is in the form of prime factorization, this is the method to find. Just we have to use to check that given number is a perfect square or not. Okay, so next method is a division method. Finding square roots by division method or long division method. Okay, long division method. Okay, just see that how to find by using the long division method. 256. What is that number? 256. Just steps, listen carefully here. That number, whatever it may be given, first we have to see that we have to just group them as pairs. Group them as pairs from right to left. From right to left. In this manner we have to group them as pairs. Group them as pairs. So here from right to left, here we have that 3-digit number, no? So from right to left these two become as one pair, and here single number is there, so on that single number we have to keep that bar symbol. Okay, so when you are grouping them as a pairs, then on that pair just you have to keep that a bar symbol. Just you have to keep that, put that one bar symbol on that pair. So on that leftover number also you have to keep that bar symbol. Okay, now here long division method. In this way you have to find. So here the nearest, the first number, what is that? That is 2. Which number is there? Whatever it may be, first you have to take that its nearest square number. Okay, it's the nearest square number we have to take, but the square number should be less than this number, less than that the first given number. Okay, so what is the meaning of that? Here the nearest square number of 2 is 1 is the nearest square number, as well as 4 also nearest square of that 2. Okay, but here 4 is greater than 2, that's why we have to go for that the least number, that is 1. Okay, so here we have to take that one as 1 into 1 is equals to 1. So take the difference. 2 minus 1 is 1. Bring down this one, that is 56. 156. Clear? That is the first step. Next, come to that second step. This is also very important. Listen carefully. So here which number we have to write means, here we have to take the double of this number. We have to take the double of this quotient. Okay, so 1 into 2 is equals to 2, or else 1 plus 1 is equals to 2 we have to take. Okay, first number maybe you will get the confusion. Second example also I will tell you, so listen carefully. So here just 1 plus 1 is equals to 2, that one I taken here. Next, here this is 2. Which number we are writing here? The same number should be placed here. Okay, that is the third point. Which number you are going to write here? The same number you have to write here. Okay, after you have to take the product. So which number can exist here? Yes, here you have to go for that the properties what we discussed in that square roots. So here this number is ending with 6. That number is ending with 6. So how many possibilities are there? Yes, only one possibility is there. Now what is that? What are the possibilities here? One is 4, another one is 6. 4 4s 16, another one is 6 6 36. Okay, 4 4s 16, 6 6 36. So here we can observe the two possibilities. So which number we can exist here? Just we have to take that the number which is less than 156 only we can take here. Okay, why? Because here subtraction means always we can subtract that the smaller number from the greatest number, no? Okay, that's why. So here 2 is there, no? So first I am keeping that 4. So 24 into the same number we have to write here also, no? So that number we have to multiply. Here 2 into something we are writing, the same number we have to keep here. We have to write here. That number should be multiplied with this number. Which result you will get, that number you have to substitute here. Okay, so just 4 4s 16, 4 2s are 8 plus 1 96. Okay, 96 is less than 156. Another possibility also there, no? So check that. Here I am going to keep that 6. So 26, the same number you have to keep here, no? So that is so 6 I am saying. So take that 6. 6 6 36. 6 2s 12. 12 plus 3 is equals to 15. Just observe that we taken here two possibilities. One is 9, one is 4, another one is 6. If you multiple with 4, then you are getting 96, which is less than 156. If you take that 6, we are getting the exact number. So which number we can consider here? Yes, this one only we need to take. So here 26 into 6, which is equals to 156. So its remainder should be 0. Its remainder should be 0, then only the given number is a perfect square. For example, here you will get that any other remainder, then that is not a perfect square. Okay, so what is the square root here? That is 16. So square root of 256 is equals to 16 is the result. So this is a long division method. I'll tell you one more example. Okay, see here. 1225, 1225. Okay, so see here, long division method. Again we have to keep that pairs from right side to left side. Here two numbers, here two numbers, completed. Next step, what is that? Need to take its nearest square. So here 12 is there, nearest square is 9. 3 3 is 9 only, no? So next square is 16. Clear? So which one we need to consider? Yes, 9 we need to consider. So 9 square root is 3. So 3 3 is 9. Okay. So 12 minus 9 is equals to 3. Put down that 25. So 325. What is the next step? Yes, double of that 3 we have to take. That is 3 plus 3 is equals to 6. 3 plus 3 is equal to 6. Next, which number we are writing here? The same number we have to keep here, no? Okay, so now we have to see that 325. So that number is having in its units place is 5. So how many possibilities are there to get a 5? Only one possibility, that is only 5. So write here 5, here also 5. Only one possibility there means directly you can write that. If two possibilities there means you have to check that one. Okay, so just multiply that 65 into 5. Here the regular mistake is here some of you are writing here, if you take that 5 and here 5, after you are taking the product of 65 into 35, that is wrong. If you take that 65 into 35, you will get this result. Okay, but we need to find the result for 325. That's why don't take that 35. Which number we are writing as a common, that number should be multiplied with this divisor. Okay, so 5 5 is 25, 5 6 30 plus 2 is equals to 32. So that is 325. So 0. We are getting remainder as 0, no? So that's why here 1225 is a perfect square or not? Yes, that is a perfect square. So what is the square root of 1225? That is 35. Is it clear to you? Yes. So in this way we can find that square roots of that numbers. To find that square root of that a decimal number, how to find that? Yes. Okay, for the decimal numbers, for example 0.16 is there. So how to find the square root of 0.16? Yes, again same process only. Just group them as a pairs. Here 0.16. So next here 0 is there. So take that one as a 0 point something. So you will get this one as a 16. Okay, so already we kept that point. Now which number we have to take? Here we have to consider that 16 only. To that 16 in nearest square value we have to take, or else 16 is a perfect square. If you know that, then take it as directly 4 4s 16. So 16 minus 16 0. So what is the square root of 0.16? Yes, that is 0.4. 0.4 is the square root of 0.16. So by using that long division method we can find that square roots of decimals also. Okay, so what we discussed in this video, just we discussed about that how to find the square roots of that given numbers by using prime factorization method, and in the same way long division method. Okay, so up to here your topic completed. So next if you have any doubts we will see in that worksheet part. Okay.